Thank you for coming to Kenzan tonight for a presentation on the ins and outs of test driving your code. So tonight we're going to focus on what is TDD, why we should practice TDD, the downsides to it. I know that some people have arguments about why you shouldn't. And then I'll run through some frameworks, runners, and assertions, just to kind of give clarity on the terminology of test driving code. And then some time for questions. So before I start, does anybody have experience writing unit tests, end-to-end testing, or anything like that? A couple of people. Oh, a lot of people. Good. So you guys want to come up and talk? Because I don't want to. All right. So first, let's start a little bit about Kenzan. Kenzan is a full-service consulting firm covering the full spectrum of software development, from project managers, business analysts, application development, and DevOps, with as little or as much involvement on the client side of things as necessary. We typically work with clients very closely, but when it's time to let them have it, they kick us out and keep it for themselves. A little bit about myself here. I'm a technical architect for Kenzan for about 2 years. I mentor junior developers in the industry. Just about anything JavaScript I'm interested in, so both on the back end with Node.js, front end with AngularJS, React, stuff like that. I'm a TDD advocate, kind of like the go-to guy here in the office in Providence, Kentucky, for test-driven questions and stuff like that. So we are going to focus on test-driven development as from the point of view of unit testing. There are integration tests and end-to-end testing. There are different terms different ways to name them, but basically we're focusing today on unit testing, which is the smallest measurable piece of functionality. So what is test-driven development? Test-driven development, Martin Fowler, if nobody's familiar with him, you should be. He is one of the leading advocates for test-driven development in the country. He's actually worldwide. But he says that test-driven development is a technique for building software that guides software development by writing tests, which is basically a way to just say, write a test for the next bit of functionality you want to add, write the functional code to pass that test, and then refactor both new and old code to make sure that you have the simplest and cleanest approach. We're going to cover this a little bit more in the next slide. It's called red-green refactor. It's the 3 steps of test-driven development, and we'll get into that a little bit more. A little quote for me that I like to share, and it's an analogy that I use, kind of to get people familiar with test-driven development and what it's all about. Test-driving your code is similar to laying concrete forms. Without the concrete forms, you end up having to jackhammer it back into place. So yeah, you may have a flat sidewalk, but in order for it to be nice and clean and crisp, you'd have to jackhammer it without putting those forms in. So the idea with the test writing the test first is doing the work up front so that the end result is cleaner and simpler, as opposed to trying to shoehorn it into something that's not really there or finding bugs as you go along. So I mentioned red-green refactor, and so I want to go through each stage here to kind of give you an example of what we kind of do in each stage and why each stage is important. So the first stage is red. We want to write a test for code that, at this point, your first test, your code doesn't exist, right? So you've got to write a test that ultimately fails, and that's your red stage. And you can see an example here. I've kind of done the setup. At the top, it's just mock setup here, but here's the test. And really all I'm asking here is something should expose a function, right? I should be able to have a public function called awesome function. And that's all I'm expecting at this point, right? I don't need to know any other logic. I don't care at this point, very first test. What's it return? What parameters does it accept? Doesn't matter right now. First step, smallest measurable. And we're gonna, from there, we have a failing test. We run this test, it will fail because nothing exists yet. The next stage is the green stage. So our goal at this stage is to write the logic and the actual code to pass that test. And a simple example of that is this here, right? It's just a simple function. It does nothing. It just exposes itself. The next stage is the refactor stage. And This actually is the most important stage of it all. This is where test driving your code and writing the test first, actually, this is the power of it all. Refactoring code is not fun, right? Nobody here wants to refactor code. Most people have to refactor code. So what we do with test-driven development is refactor as we go. That ensures by the end of the task, we have the simplest, most easy to read and maintain code as we can. So when you write the code in the test first and refactor as you go, it forces you to stop and look at what's there. It forces you to say, hey, I've done so much so far, how can I clean it up? Can I clean up any loops that I may have? How about conditional statements that may be a little bit wonky and you're not too comfortable with? Because you have the test to back up all the logic that you've already written, you can change those lines of code in any way necessary and still have a passing test. As long as those tests pass, your code works. So it's important to really look at it every stage and never skip the refactor stage. Because when you step back and say, hey, I don't want to write my test first, but I do want tests to back up my code. So I'm just going to write the code and then come back and write tests. Well, there's a bunch of problems with that. What if the code doesn't work? So now you have broken code that you assume works, and then you're writing tests to make sure your broken code stays broken, because it's never going to fail. The other problem is, when you refactor, you don't have any test data to refactor yet. So you have to then write the test to refactor the code. Well, if you did it this way, you've already had the test, you've already refactored it, it's already as simple as it can be. So you start to really you end up starting to create really elegant looking code that's very easy to read and very easy to maintain. So going back to our example, it's very simple refactoring, but you can see here that I don't have to have just a simple export statement that's spitting out my service. I actually wrap it first and I can create a local variable to store it, and then I replace it. So very simple refactor, but you can see that there's a difference here. Now this may be preference and people may prefer the other way, but this is my preference. I'd rather have the constant set up first, and then we refactor as we go. So why should we practice TDD? And I hope that I've given some examples already, but I want to go through some benefits on both the developer side, but also on the project as a whole side, right? So developer benefits, you increase confidence, you avoid context switching distractions, and writing tests is fun. So first thing is increasing confidence. You can make changes to the code knowing that things aren't broken, right? If anything does break, it breaks locally before you push it to GitHub or before you let anybody review it. Failing tests locally is a good thing. And inevitably, you will break your code because a new feature is going to come in and you're going to have to add something or you have to rename something. And that should set off wildfire somewhere saying, hey, wait a minute, I was depending on this method to be called method A and somebody changed it to method B. Well, things are going to blow up. And if you don't find that soon, you will find it in production. And it won't be you finding it in production. It will be your boss or your boss's boss. And it will come back to you. And you don't want it to come back to you at that point.
Or your customers.
Or the customers, which is even the worst thing. You don't want the CTO of your client to find the error and say, hey, wait a minute, this was working last week and now it's not working. And that's one of the primary developer benefits is that you have confidence to make these changes. And also, it allows you to move on to the next task without having to worry about the previous task that may come back to me. Task A gets finished, task A moves on and never comes back to your desk. Task B can then be focused on and move on forward. The next benefit is you avoid the context switching distraction. And I don't know if I coined this term or if I just made it up or whatever. It's something that I've noticed. My improvement since I've been test driving code is you eliminate the need to go to the browser to refresh it and come back to the code to make a change, save it, go back to the browser, refresh it. That is context switching, and that's a distraction. So it may only take 1 to 5 seconds for your brain to switch from code to the browser and then back to the code. But those 5 seconds add up throughout a day, throughout a week, throughout a month. which could lead to minutes or hours of your time. All you're doing is switching context. Your brain is only switching context. So by staying with a single view, which if you use WebStorm, you will have that single view. You can have your terminal window, you can have your test running, and you can have your code all right in front of you in a single view. You never have to move that context, right? Your brain stays focused on writing the code. You have a build that's going to run the test every time you save. You are actually saving time because you don't have to switch that context. You are saving the test run in less than a second, boom, you're on to the next one. And you can continue to work there. And the next one is writing tests is fun, right? I honestly, this achieving a green success message, it's like a reward system. It tells you, yeah, you did the right thing. As long as you take the time to set up your test cases the right way, and you say, okay, my tests are set up to mimic my environment. I know that my code, if passing, mimics my environment in production. So you can then feel good about it. You feel good when you submit that PR and you say, this is great. I got total coverage. I got all my use cases covered. And now I can pass it along and create my PR. That's confidence. That's happy. There's no stress in that. When you submit a PR on certain code, you're stressed. You're worried, oh, what are they going to find? And then when you see an email come in or a comment on that PR, your gut drops. I know mine does. Oh, crap. What did I forget? What did I miss? What did I break? And those are the types of things that writing your test first gives you that benefit of confidence, right? So it's not just the developer themselves that gains the benefits of writing tests first and having that confidence in the code working. It's actually a project too. You increase velocity and you protect against regressions. So velocity, you can see here, it's almost the whole gamut of the project team. Developers are less likely to have to return to a completed task. So I mentioned earlier, task A is complete and you move it along. If that comes back, now task B is on hold and you have to go back to task A. And now again, your context is switching. You were working on the user login, now you have to go to the shopping cart, and now you have to go back to user login because something was wrong. Your brain, although can handle it, is still taking time to shift, and your momentum is killed, your velocity is killed. Tech leads and product owners spend less time reviewing the code. They don't have to go into the nitty-gritty to say, oh, wait a minute, this isn't working here, or this isn't working here. If they take the time to write the acceptance criteria ahead of time, then you can add those acceptance criteria as your unit tests and your use cases. So if they give you ABC, and you write tests to cover ABC, and they see the test as ABC, hey, I don't have to check anything. I can trust the tester here. QA team is basically the same thing. They can see that the tests are written, the feature's working, and they can feel comfortable that if there was a regression, it may have happened already, and the developer caught it. So by the time it gets to the QA's desk, they don't have to worry so much. Now, their job's not done, of course. They're going to have to do something, but it's less effort, it's less worry, and they have more confidence. And the DevOps team, they're the ones pushing it to production. They're the ones that are on a high alert when somebody says, hey, there's something broken in production, we have a hotfix coming right now, we'll let you know when it's done. Well, what do you think they're doing? They're sitting around waiting, maybe, hopefully. Not here, right guys? Not here. But no, the idea is you don't want to stop anybody. You want momentum to keep moving forward. And by not having to bother the DevOps team to do hotfixes, you let them do what they're working on, whether that's increasing performance or whatever it may be. And also protect against regression tests. Again, I'm just beating a dead horse at this point. You gotta understand that when code is tested, we expect things to get caught. When things change and things break, we want them to be caught locally. Breaking tests locally is a good thing, and they're inevitable. They will happen. So don't be afraid when you write a test or you change code and you see 30 errors. Good, 30 errors locally at your local production. Now, before you get to production. So the next step from there is how do you address those 30 errors? You can either A, fix them right then and say, okay, I changed the method from method A to method B, I changed it all over the application, we're good to go, perfect. Or if you see that it's something that's out of your realm or not part of your task, you then can alert your project manager to assign it to the right person. Again, this stuff is caught before it goes to production. Clients aren't seeing it, your managers aren't seeing it, you caught it first and caught it quickly. So here's a lot of text on the screen. Test-driven development should not impact the process, right? Can anybody see the difference here? The only difference, I'll help you, is right here. Development is completed with testing, right? This is without testing. That's the process is ultimately the same. Now we come here, and again, the process is just about the same. And here's where things start to take a little bit of a different turn, right? You see that feature spec and ticket creating are about the same. You know, about half a day between sitting in a meeting, getting the specs, getting the ticket, and getting it assigned. The developer takes 1 day to get it assigned and finish the development. They pass it on to the tech lead or whoever's doing the review for a smoke test. They spend about a half a day. And this is arbitrary numbers. I'm making numbers up here. This is just for visual effect. So we spend about a half day smoke testing and making sure that, okay, the new feature's in place. I didn't see anything breaking. It looks okay to me. And then move it on to the QA team. The QA team can then regress and look through and make sure that nothing's broken. If anything breaks along the way, it gets assigned right back to the developer, and the whole process starts over again. So, for an example of this, I have a little bit of text here. Forgive me for reading it off the screen. Developer completes task A and submits it for review. In the meantime, moves to task B. Before completing task B, task A is returned during the the PR issue there. So the reviewer saw an issue and sent it back saying, hey, you gotta fix this stuff. The developer must stop with his work, whatever that may be, on task B, and now go back and fix task A and submit for review again. So now the developer has touched the problem twice, and now the tech lead has touched it twice, reviewing it twice. The tech lead says it's good, push it off to QA. QA looks at it, well, found a regression. Your feature's fine, but there's a regression now. So now they make task C as a bug, right? So now there's a new task in place, but it's really the same issue. You broke something, you need to fix it. But now there's an extra ticket that's being tracked. The task C is assigned to the developer fixes it, and the process starts all over again. Now you have the tech lead and QA and yourself touching it 3, 4, 5, whatever number of times, constantly, just to get one task out the door. All because they wrote the code first and wanted to see the review. It's test-driven, it's a little bit different. Now the numbers don't change much, but where they're allocated does, and here's why. Developer works on task A using TDD and submits the code with confidence. He knows he's covered all the use cases, so the product owner is going to be happy. Everything that was supposed to be there is there. The tech lead can spend less time, as I mentioned, because they can see the test outlined the use cases. As long as the tests are there, and the tech lead at this point is really looking at the test. Okay, the tests are set up, the environment's right, everything's looking good, and everything's passing. Good, I'm happy. They can make syntax things, clean up this, blah, blah, blah. Those changes at that point at the PR review are minimal because it's going to be more about syntax or cleaning up the code rather than you missed something or this doesn't work. Well, of course it works. I wrote tests for it. If the spec was wrong and the user cases are wrong, then that's a different issue. That should have been found out at the top, at the feature spec, or at the tickets. That's when the acceptance criteria gets added. When it gets to development, the developer's just following directions at that point. The directions were wrong. Well, the directions were wrong. So once the tech lead approves the PR, it gets merged and gets moved on to the QA team. The QA team now doesn't have to look for so many regressions. The regressions should have been caught. You changed method A to method B, I see that in the PR, but I see that you went through 50 other files and made the changes elsewhere. Great. I'm not too concerned about regressions happening for this particular feature. Now, of course, they do the smoke testing and they may run their end-to-end testing. However, they're spending less time. Now, in this, I know the numbers add up a little bit less, and again, they're just arbitrary, and I was trying to show you that there's savings here. So people argue that testing takes longer. Well, sure, it takes longer for the developer, but it takes less time for the rest of the team because they're only touching things once. The developer may touch it for twice as long, but his context, his mental context, is only on a single task at a single time. He doesn't have to worry about the task coming back or stopping an in-progress ticket to move on to something that's already been done. So what really improves here is not necessarily the time, although my math here does show that it does improve. arbitrary numbers. The idea is that the process improves, right? People are working forward as opposed to standing still and waiting or going back in time to fix something that would have broken. So now that you've heard all the benefits I feel that TDD brings, let's talk about some things that others argue aren't that strong. So what about timelines? It'll cost more and writing tests is hard, right? So timelines, yes, testing takes longer, but at what value? If a developer is going to take 2 days on a ticket and he tells you up front, it's going to take me 2 days to write the test and write the code. Great, you told me up front 2 days. If you tell me 1 day and then the next day a bug comes back and you're going to work on it again, and then another regression comes back, well, that's 3 days potentially that you worked on a ticket that you said was going to take 1. So by planning and having that stuff up front, you maintain velocity, you maintain working on completed or non-completed items, you keep moving forward. So that's my argument about timelines. If you plan for it, they don't take longer. You've expected them to take that long and you get them completed. The argument of cost. When you are not having to revisit and your estimates are on point, the cost of the project stays on budget. There's no need to worry about, oh, we have a hot fix here, and somebody called me on a Saturday and they ended up working 8 hours on Saturday because there was a bug. None of that really happens. If it does, then it's much less frequent. And what's most important is that developers are paid to move forward and work on new tasks, as opposed to working on tasks that they should have completed on Monday. Now it's Thursday, they're still working on the same task because they waited for the offshore QA team to QA it, and it took 24 hours for them to get back to them, and it got into their email box. Oh great, so something I thought was done on Monday evening, Thursday morning I come in and I have to fix it again. Great. Now I've spent 4 days in my mind thinking it's done and it's not done. Now I have to switch back. I'm discouraged, and my boss is certainly on my throat because I didn't complete it in the time. And writing tests is hard. There's no doubt about it. It takes time, it takes practice. But we're all here, right? We're all willing to work hard. We're all willing to do what it takes to get something done right. So just practice, write your tests, and see as you go what valuable tests are. Focus more on on what's happening as opposed to how it's happening, right? So instead of testing, I'm making a call, and this is an AngularJS example. I'm making a call using HTTP request or an HTTP service. And if you test that and you lock that into stone in your test, anybody who may want to change that to maybe use the resource service is going to fail because you focused on how they were making the call or the request as opposed to it was made. I don't care how it was made. I just needed to make a request to a server and come back with data. I don't care how it gets there because the data is important. That's what's important, not how I get it, but that I have data. Over and under testing. So this is something that I am guilty of, completely guilty of, and unfortunately, there's no support meetings for this type of stuff. So if anybody would like to support over-testing AA or whatever it may be, please invite me. So under testing is, basically ask yourself, can you change the code without anything breaking? If your answer is no, you're under testing. Things that change in the code should have some type of warning signal saying, wait a minute, you changed something that was supposed to be in place. So if developer A implements a feature, and 6 months later, developer B comes in to say, hey, you need a new feature here. You need to extend this feature. If they change something and nothing breaks, terrible. Now that new developer B, has zero confidence that what he's going to change is not going to work. He has no idea. So he's just going to shoot for the stars and hope that it works. Another way to test it is if you comment on a line of code. Does it break? Does something break? It should, right? Because you've just changed the logic. You've changed something. On the inverse of that, you have over-testing. And this is what I was mentioning before. You want to focus on what it's doing, not how it's doing it. And the example I always give for this is more generic than the Angular example is concatenating a string. If you need a string to be concatenated and you need the first and last name to be spit out as a single string. I don't care how you do that. If you want to loop through each character and make a new string and just say, this is the new string, I don't care. All I care about is the return value. If you want to, use the plus and get it all concatenated, great. Again, I don't care. All I care about is that this method returns a string and it should be the first and last name together. So that's the type of stuff you want to do and focus on. And the third one I want to talk about is the Goldilocks area. And that's I just picked that up from Mountain Fowler. If you're not familiar with the Goldilocks spectrum, I suppose if you think of temperatures, there's extremely hot temperature, extremely cold temperature, and something in the middle is that Goldilocks area. It's like the three bears, right? She found that porridge that she loved. So that's what the Goldilocks area is. You want to find something in between over-testing and under-testing. Something that when you change the code, it breaks, but not focusing on how things are done, right? So it's going to take time. You're gonna have to get used to it and start to see that it's an experience thing. It really is. And if you start today, in 3 easy months, you'll be there. No, I'm just kidding. So with all of that, I want to go into the actual practice of testing and see, and it kind of clarifies some of the terminology that's there. So the first one is frameworks. Jasmine, Mocha, Jest got a little asterisk, and I'll mention that in a minute. But what this framework gives you is the testing architecture. The describe blocks, the if blocks, the before each. It's basically, I mentioned earlier, mimicking your production environment. You need to say that my code runs in this particular environment. That you need to set configuration variables, you need to import dependencies. You need to make sure that your code can run in the test suite. And that's what these allow you to do. They actually set up the actual test suite itself. So there's two primary types. There's an all-in-one and it's piece by piece. So all-in-one is you give you assertions and the test setup and the expects and all that stuff. All-in-one solution. Jasmine and Jest are options. Are examples of this. And a piece by piece solution. Let you pick and choose, okay, I want this for my framework, I want this for my assertions, and I want this for my spies. And you can really pick out what you want. Test stacks are usually chosen based on the project, and they should be kind of determined before you kind of get started. Switching frameworks, switching test stacks can be kind of tedious, especially if you've had hundreds, if not thousands of code, tests written already. It's a pain in the butt to go back and have to change any syntax that may be there. So assertions. Assertion libraries allow you to validate what's happening. If you've heard of, I expect this to happen, and you saw in my example, I expect a method to exist. And that's what the assertions do. Specialized assertions are available. So Chai provides plugins. Chai is an assertion engine that we'll cover in a bit. So Chai has these plugins that allow you to really assert on different types of things going on. One that's really common is Chai's promise. You can assert that your promises are inevitably going to return something. All right, so it's a way to test promises and stuff like that. But the links at the bottom, I know they're very small. They didn't look so small on my screen. You can check out chai.js.com/plugins, and there's a whole list of plugins there for that.
Those are all open source?
I'm sorry?
Those are all open source?
Yes, sir. Yeah. Spies and Stubs. So Scion is my preferred spy library. There's a slight difference here between the two. I'm sure if you've heard of Spies and Stubs, you can kind of use them interchangeably, but the spy is really just there to kind of keep an eye on things, to verify action items. I expect my method to call method B of this other service, and it should be called with this value. I can then say, oh, yes, my code did actually call that, and that's what spies do. Just keep an eye on a function or something, and it allows you to say, yes, it's been used. Stubs, which is very similar to spies, where you can kind of keep an eye on specific methods, but with stubs, you can actually control what happens. So think of something that may return an error. or may not. So you want to be able to say, I expect this method to be successful here, and then the next test you can say, I expect to fail for this reason. And then you can control the outcome of that method call, that library, dependency call. And I mentioned here that it allows for coverage of positive, negative, and exception use cases. So by stubbing, you can really make sure that you're covering all your use cases and ensuring that even your errors are covered by tests. We want the errors to come up. If something goes wrong, we want to make sure that things get logged either to the console or on the screen for the user to see. So we have some utilities here. Code coverage, if you've ever heard of Istanbul. Istanbul is a means of providing reports on how much of your code is actually tested or covered by tests. So they can be a little misleading. There are ways to trick Istanbul or the code coverage library to say, yes, that method has been called at least once and it's hit every single line inside of that method is 100% covered. The problem with that is that method may be 50 lines long. Well, what's going on in those 50 lines? You need to be more specific. You just can't say, I expect that method to have been called, and that's it. You need to make sure that you're really diligent on what's going on in those methods to make sure that if something changes in there, the code and the test do fail. So code coverage, you may hear clients and people stressing that we need to get the coverage up, we need to get the coverage up. What's really important here is you need to have valuable tests. You need to make sure that what you're testing is important, and you're not just throwing in tests to get high coverage. Because again, they're misleading. You might say, hey, this is 100% covered, and have one test. Well, that's not 100% covered. You need to make sure that all the use cases that may potentially happen are covered. So if somebody calls that method with the wrong attribute, what happens? If somebody calls it with an attribute, but it's a wrong type, what happens? Those are the types of things you gotta kind of think of when you're talking about code coverage. That's the value. The code coverage number that spits out is really irrelevant if the tests aren't valuable. And React.js has a couple of utilities. Test utils is provided by React, and Enzyme is another way to manipulate the virtual DOM and to assert that the virtual DOM is rendering properly. So test runners. Test runners allow for automation of the test. So you can sit there all day and call a single test through the command line. What that doesn't provide you is a test environment setup. I mentioned before that you really want to have your test environment mimic your production environment, so that when your tests run, they're running as close to production as possible, but abstracted from production. What a test runner does is allow you to configure it to import, if you have 50 vendor dependencies with Angular or React, you get all these different plugins, to try to include them in a test environment becomes really tedious. So the test runner like Karma and Enable can really allow you to be very specific on what dependencies are included. So the configuration, they're very simple to get started. So you can really get a Karma config really set up through the command line. They have a command line command that allows you to kind of spit out a Karma config, and you can start running from there. But you can really get advanced options as well. You can get into multiple browsers. If you want to run Safari and Firefox and Chrome, you can set all that up so it will run the tests in those environments. With that, you can also get third-party integration. If you've ever heard of Sauce Labs and BrowserStack, it's basically a cloud-based service that allows you to have an infinite number of kind of environments. You can say on Windows, I want Firefox, these three versions of Firefox. On Mac, I want these, and so on. So you can really look at your user base and say, okay, this is my demographic, this is what they're using, and I want to make sure that it's working on all of that stuff. So here's a side-by-side kind of example of the all-in-one versus piece-by-piece. So on the left side, you have an all-in-one. Jest and Jasmine are your examples here. And they give you basically everything you need. You can get right up and running with this, and there's no fuss, no muss. The piece-by-piece, which is actually my preferred stack, it allows you to kind of like pick the pieces that you want and only use those that you need. Between these three, Mocha, and Scion, I almost never have a test stack without those three. Those are my three preferred, but you can pick any type of assertion engine you may want. And Scion is the same thing. If you find a better spy library, please let me know, because I haven't found one. But Scion is fantastic, and between Chai and Scion, I'm usually able to get 100% coverage on most of my code, regardless of how deep the promise nesting may go. That's really thanks to Scion and some of the stuff that offers there. So we've described TDD, and we've talked about the benefits of practicing TDD, both on a developer and from a project perspective. We've debunked some common concerns, and we've defined some testing keywords. And we've looked at all-in-one versus piece-by-piece type test stacks. Are there any questions?
I know Kenzan, you don't do a lot of mobile, but would this work, this kind of architecture, or whatever you want to call it, work for mobile? I mean, would some of these frameworks work?
Sure. Yeah, so the question was, do these types of examples work with mobile? So if you're making mobile web apps, absolutely 100%. And what I wanted to stress here tonight, and maybe I should have had a slide and mentioned it, these practices and policies, so to speak, are really universal. You can use these types of things anywhere. I use JavaScript examples because I'm a JavaScript developer, and this is what I do. But ultimately, you can do this in Java or PHP, Python, whatever you're working in. You can take these principles and apply it there. The idea is to just write your test and keep the code as small and concise as possible. So I'm not familiar with mobile app development, so I'm sure that there are testing frameworks out there for that. Unfortunately, I don't have them off the top of my head, but if you take the policies that I've discussed here, you can certainly apply that just about any project that you work with. Sure.
Are the testing frameworks you mentioned, are they language independent, or are they specifically JavaScript testing?
The stuff that I covered today, the examples I covered, are specific to JavaScript. So again, I should have probably mentioned that I was hoping to cover philosophies of test-driven development as a whole, as opposed to strictly for front-end development. This is certainly not a front-end web type of thing. This is for any project out there. And I believe, and I'm not a Ruby guy, so forgive me, but I believe Ruby on Rails was actually created with the idea of testing. Right? I'm sorry?
Our spec would be a test.
Our spec, okay. And I know that the Angular framework as well, the AngularJS framework, was created with testing in mind. So it is a common practice, and you will have pushback. There will always be somebody pushing back saying, it takes too long, we don't have the time for that, it's going to cost us too much. Hopefully today I've clarified that if you just plan for testing and you make it part of your workflow, you aren't spending any more time, you're actually potentially saving time, and you're a happier developer. That's really what it comes down to. Your day-to-day tasks are made simpler and less frustrating, and you can feel more confident working in your projects. Sure.
Does knowing that you're going to write tests for your code affect how you write code?
Oh, great question, great question. So, for the audience, the question was, knowing that you're writing tests, does it change the way you write code? Is that correct?
Right,
All right.
Less dependencies, less...
Right. So the idea, and you want to start really basic, right? So yes, instead of looking at a holistic solution, say, okay, I know the get name, I need to do this, I need to get the name, I need to concatenate it, I need to return a string, I can do that. And you start coding right away, and you start with that, let me get the data, and let me parse and do it. But if you switch it, and you start writing your test first, what you change is your thought process. As opposed to being holistic, you're looking more at measurable units. What do I expect this to do? Well, first it's got to exist, right? That's always the first one I write. Because to me, if it doesn't exist, then nobody can use it. And then from there you can say, what's the smallest detail of this method? Well, it's supposed to return a string. Okay, I expect when this method is called to return a string. Now that test should never fail, regardless of what other logic is in there. That's the basic of that method, right? So yes, your brain will adapt to it, and your process will adapt. It will take time. It took me 3 months, 5 months to really grasp it. And I actually, my first time test driving code, and excuse me for the little aside here, my first time test driving code was actually in an interview. They brought me in for a code review, and they sat me down next to my manager, my soon-to-be manager, and said, okay, write tests. I've never done this before. Give it a shot. Okay, what do I do? Give it a shot, go for it. So I sat there for like 10 minutes, 15 minutes, like looking at this guy, asking him questions with nothing written on the screen. He would not help me. And that's because he knew that it takes time to learn how to do this. And so by working it out and talking to yourself, or even writing notes down to say, what am I trying to measure? What can I really do? You start to switch that thinking, right? So you do have to change. Good, you got another question?
And also, I guess to carry over onto my next question is, so does that force you to break down like a function from doing too much into like two different functions and then writing tests for those two different, so like you avoid making spaghetti code and that kind of thing?
Yes, great question. Again, does it allow you to take a different approach and maybe see code smells or things that could be abstracted a little bit further? Absolutely. And that's really why I stress the refactoring stage, because that's what you see in the refactoring stage. You may write a method that's doing 3 things. Well, it's really difficult to write tests on those 3 things all together. But if you break them out to 3 separate methods, you can now test them individually and say, okay, I know that method A works, I know that method B works, I know that method C works. Anytime anybody uses them, they're going to work, right? And so that's what you get to see. So your first time through, you may start to say, okay, I'm doing this, and doing this, and doing this. And then your 10th or 12th test, you may say, wow, I can really clean this up now. You have 12 tests passing. You can do whatever you want. And I don't know if I stressed it. I don't know what even the slide is on if I go back. Here, when you're refactoring, you don't necessarily need to just refactor the new code you just added. Refactor everything on that file, or in that method that you're testing. Refactor it all. You have the test to support yourself. You are a tightrope walker, and you have a safety net. So do whatever you want. You want to do flips, you want to jump, you want to do whatever you want. You have the safety net to protect you. So that's where the refactoring stage really comes into play. Your test and your file should be clean and readable from the human point of view. Any other questions? Sure.
If you're, I'm not sure how to phrase this, but if you're changing, like if you have a function that you end up thinking it's got too much, you're going to change, are you writing some of your testing on the fly there? Are you going to change how you're doing your testing? Or?
So the question is, sorry, can you repeat the question so I can repeat it for the mic?
It seems like if you're changing functions like that, changing the function that what they actually do, like potentially separating things out,
Yep.
that you might have to write more test cases, or you might have to change your test cases.
Yeah, absolutely.
So you may be doing something on the fly.
Yeah. So if you start to see that you can break something out, you may move your test around because one method isn't doing what it's supposed to do anymore. That doesn't mean the test isn't valuable. It's just in the wrong spot. It's at the wrong time of the test suite, right? You may want to move it and say, when I'm testing method B, this is the test I'll be writing. I previously wrote it for method A, but now I can move it somewhere else, right? So you can start to see that. What I would always say is, do not, please remember this, do not refactor in the red zone. Do not refactor in the red zone. And you will regret it. I promise, you will regret it. So get to the green stage first, and then do whatever you want. Because once you get to the green stage, you can't break anything. Well, you can, but the tests are going to tell you. All right? As soon as you break something and you're in that red stage, stop refactoring. You broke something, do not go on. Go back and fix it. Okay?
That's why version control is awesome.
Yes, version control. If you're not using version control for test-driven, please get into it. Because even when you break something and you make a mistake, you can revert. Even if it's already on GitHub, revert back and get back to where you were. Okay. Any other questions? Sure.
Commit early, commit often.
Yes.
What do you think is the easiest method to get into testing? The all-in-one or the pick-and-choose kind of?
All right, so the question was, what's the easiest way to get into testing, framework-wise? Which framework should you choose to get into? The syntax really isn't really that different. So from that point of view, you're not going to have an issue picking up Loco or Jasmine. From a starting point, most people go to Jasmine because it really is a one-stop shop. You can get it installed, and once you get it up and running, there is no concern about making sure that you have Scion brought in and working properly. Jasmine's going to give you the spies and the stuff that you need. So ideally, you're probably going to start there. Once you start to see, hey, I don't need all of this, and Jasmine's a big, big library. You may not need it, you may not want it. And I actually prefer Mocha for a couple of other reasons, but the syntax is easier to read for me. Jasmine uses a lot of camel case, where Mocha does a lot of dot notation. And that's really just a preference of mine. But yeah, so Jasmine is most likely where you're going to start, but I know JP, which will be talking after me, was going to cover Jest. And I had a little asterisk about Jest, and I didn't mention it. I'm sorry, I should mention that now. Jest is a little bit of a combination of everything. It actually gives you a runner, assertions, framework, everything is all within a Jest, right?
On more.
And more. Well, see, that's why he's giving the talk, not me. Yeah, so that's where it goes. Any other questions? Sure.
Is it possible to do test-driven development like this if you're kind of the only one doing it and not everyone else on the other team? A couple people.
I do. Yeah. So the question was, can you do it by yourself, or should you really keep it in a team environment? No, do it yourself, because it's your confidence, right? You know that it works, and that's what makes a difference. You can really feel good that I'm releasing this to the public. Nobody else has touched this code, but it's going out to the public, right? I'm trying to make money in this app. I'm trying to release this and get a buy-in or something. You don't want anybody else to see an error, especially if you're trying to market yourself as a new developer. If you submit code to me and I'm going to review it as an interviewer, and I see bugs, well, you didn't even QA your own code. Like, problem. You sent it to me and you got test. Oh, wait a minute, I'm impressed. Because now you wrote the test, took the time, but I know it works, and you know it works. So it is a difference. Personal feeling inside that your code does work.
It's kind of like that insurance policy that we talk about.
Right.
Sometimes it might not be tangible right now, but 6 months from now, I think how you agree to it, whether it's you or someone else that comes back to it, and then they casually go in and change something and things break, they get that immediate feedback. Like,
Yeah.
oh, what I did now returned was false instead of true.
Right.
I can start to narrow down and figure out what my things on the code
Right.
to do and learn as I go.
Yeah, and there's not many developers that can work on something and then 6 months or a year later come back to that. Even if you wrote it and nobody else worked on it, it's going to be difficult to really get back into it. What was I trying to do at this point in time? One great thing about tests is that if you describe your tests properly, they read like a book. It should do this, it should do this, it should do this, it should do this. Okay, well, you just documented your code. So now you wrote your test and you documented it all in one step. And now the next developer or yourself back in 6 months can come in and say, what was this supposed to do? Oh yeah, it does this, it does this, it does this. And it still works. So then you can come in and say, well, I learned ES6 now, and I want to take this ES6 stuff and make it, ES5 and make it ES6. Well, the test is still relevant, right? It's all the same thing. You just have to change the syntax. But now it's a little bit different, so you may potentially catch yourself, which is great. So testing for yourself, just confidence. It really is, if you visualize yourself on a tightrope, looking down, there's where you're going to test. Below you, catching you if you fail. Go ahead.
One more.
Yeah.
Sorry. And this may be a dumb question, I don't know. How do you ensure that you've kind of gotten all your use cases up front?
Oh, great. Okay, so the question was, how do you know you've gotten all your use cases? Up front or covered?
Well, either or. I mean, at some point you're coming, I realize that if you're changing something, you may be building use cases on that a little bit.
Right.
How do you get to a point where you can say, yeah, I feel good about at least what I cut there for use cases?
Okay, so in the real world, and in our world here, I don't write use cases, right? I get them from somebody else. Well, it's their job to make sure that they have everything covered, right? So at that point, they give you 5 use cases, and you write your tests to cover those 5 use cases. If something comes back and says, oh, we need to do number 6, okay, well, that's not a bug, that's not a problem, that's not something, that's a new spec, right? So then you can easily go in and add that test and say, okay, here's a new use case, I expect it to do this, and you can just test that way. If you're writing your own use cases and you're developing by yourself, creating your own application, take the time to really spec it out yourself. Take a half a day or a day or whatever it may take to really say, what am I expecting this piece of functionality to really do? You want to do positive paths. You want to make sure that it does the right thing. You also want to know if something were to happen, the database returns something wrong, or if there is no database, right? That's in a 404. What happens then, right? And you want to make sure that you have your exceptions, and to make sure, okay, I want it to throw an error. I want it to blow up at this point on purpose. And those are the types of things that you outline yourself at that point. Because it's your name, it's your code. You want to make sure that it's ironed out. One thing I would suggest is if you start coding and you realize that you've messed up or you've made the wrong spec, get to a green spot before you start to change again. Okay? If you start to refactor anytime in the red stage, you will regret it. I promise you will regret it. Any other questions? One more.
How easy is it to set this up in like a lamp stack environment?
It's pretty straightforward. Pretty straightforward. So if you're looking for back-end testing and stuff like that, in Java or anything like that, that's a little bit different. But all this stuff that I showed you tonight runs right in the terminal. So you don't need to have any type of server. It runs all that for you.
This stuff can be run with
Node.js, right? So
Is it lamp stack or?
he said
Yeah, for PHP, I've done PHP unit, and there's also ways that you can try and automate it. So one of the kind of big things is, having something that watches for file changes, so when you change it, it'll, repile or redeploy or whatever it is that your workflow requires. So you can get similar experiences with PHP, similar things with Java. In fact, I think for kind of the work that we do on the back end, which is primarily API-based work, unit tests and integration tests are super critical. But they're also a little bit easier to kind of reason about, and so there's those advantages. But and for lamp stacks, we would use something like Baker or Docker to ensure that everybody has the right configuration and version control that with the project.
What did you say that PHP thing was again?
PHP unit.
Okay.
It's influenced by JUnit.
Yeah, I've used
There's
it.
also QUnit is a JavaScript representation, although it's not very popular anymore, but I think it was popular in the jQuery years.
Yep.
So,
You've been over PHP game for a while.
Any other questions?
subsidiary,
Okay. Well, thank you.